Dear students, so this second class of Environmental Engineering 1, as I explained in the first class, this is population forecast. Okay, see population, so some theoretical part, the population factors, what are the factors that depends on population, increase or decrease, whatever. Number one, it is by birth or death, just some common theory. Then birth and death, it is by migration. Okay, and we another factor also there we call it annexation. So annexation, say for example, like uh, the Americans, they used to go to Iraq or Afghanistan in a troop. So where they are going to make the camp, they have to make some water treatment plant or some water source, right? So suddenly the population jumps over there due to the annexation there itself. So this is just a factor, but we are not going to think much. But in 2 marks in public service commission or any GATE exams, these points you have to remember. The population, what are the factors it depends on by birth or death, by migrations, by annexations. Okay, so these are some few points you have to remember. Now, different techniques. First one, how to forecast the population. There are different techniques. Number one is we call it arithmetic mean. Okay. Number one, what you have to remember is the population is always forecasted at the beginning of a decade. Say, for example, 1971, 81, 91, 2001. Once the decade is over, then the next year, the population is estimated by the concerned state or the country. So, by arithmetic mean, we are going to forecast the population in decades. Number one, what it says is, in arithmetic mean, this is for, population is used for, say, small town or cities where population growth can be controlled. Okay, and the formula is given by Pn is equal to P naught plus Nx bar. Don't worry, this Pn is, I'll give you one another example over here. In 1971, 1981, 1991, 2001, 2011, you've got a population of say A, B, C, D, E. These are the populations. Okay. So PN means you want to predict it for 2041. And this, the latest population, this is called P naught. Okay. This is PN. And here N is called the number of decades. So after 2011, it's going to be after 30 years. So here N is called to 3, not 30. It is in decades. Decades means 10 years. Okay. So the initial population plus the population that what we would like to forecast is initial population E plus N. N is 3 times X. What is X? X is, you don't worry, I'll do it. X is called to average mean. Since it's an online class, I'm trying to club all the techniques in a single numerical itself, rather than solving one by one. Okay, so this is arithmetic mean. So from here, I think you're almost clear. Let me solve a numerical, then it'll be more clear. Okay, this is number one. Fine. So, or I can write here, P naught is called the initial or the last population. Last population. So let me show you some other things. Second technique is, we call it, these are all mathematical terminology, geometric mean. It's getting a little bit of weight. Okay, the geometric mean Pn is equal to P naught 1 plus R by 100 to the power n. Don't worry, I'll give you one by one. Okay, let us solve the problems, then everything will be clear. This Pn and P naught is same. R is rate of increase. Okay, number 3 is incremental increase method. The formula is Pn is equal to P naught plus Nx bar plus n into n plus 1 divided by 2 into y bar. Here you will get a new terminology called y bar. Don't worry, let me solve the problem, then I'll explain it. Fine. So these three are main numerical point of view part. 1, 2, and then 3. Okay, so remember these three equations. To make it remember, it's very easy. Initial population plus the number of decades into average population growth. Here, rather than nx bar, it is rate to the power n. Here it is, this part is the average arithmetic mean. This is n into n plus 1 by 2. This is the formula of the sum of the first n numbers, n natural number, right? The sum of the first n natural number into y bar. Y bar is incremental increase. So let me give you this three formula. You have to remember, and then let me explain you some other theory also. So first, let me solve the equation or give a numerical having all the three things. Okay, in case if you want to have an equation again, you pause the video and have a look and write down in your notebooks. Fine, clear? I think the video is still on. I have to be very aware. Fine. Okay, I'll solve an example right now. In the classroom, actually, solving itself, I solve with the students, I check the errors, I check the mistake of the students. It takes time. But here, since it's a one-way class, I'm just doing by myself. So this, in a very short period of time, will cover more topics. So let me pick up one of the examples, very easy examples. Okay. So, say for example, in 1970, 71, 1981, 1991, 2001, 2011, and you have to estimate it for 2031. Okay, the population is, say for example, here 237,98624. This was the population. Here 469,78325 54786 437 634 634 67 823. This one is 69077 421. Okay, this was the population. Now, what we have to solve is right now, we have to find the arithmetic mean. So, the first thing is this is the mean. Okay, now please remember, we are going to find, or this is not mean, but this is increase. So, in 1981, please see to it, this part, this to how much it increased, this minus this. Okay, how much it is increased from 1971 to 81, it is going to be 1981 minus this. Okay, so if you minus it, or rather I will say this is A, this is B, this is C, this is D, this is E. So here it is going to be B minus A is equal to, I'll make the shortcut, it is 231,79701. And please, when you write this value, I purposely write the value over here. Please don't write it over here, somewhere in the gaps. You rub it off again. It is for easy numericals. Right in the second line, the bottom part. Okay, 231,79701. What about this? This is going to be C minus B, and you have to write at the bottom. 7 minus 5 is 2, right? So it will be 7808112, right in this line. Next one is again here D minus C. How much population is increased from 91 to 2001? That is 8681386. Okay. Similarly, this is E minus D, that is 5609598. Okay. Now, if you make all this point, all means this one, this one, this one, this one. If you total it, total is equal to 45278. 45278 797. Therefore, x bar, average mean, average is equal to total divided by how many? 1, 2, 3, and then 4. 4 growth rate divided by 4 is equal to 11319. 11319,699. Okay, now look over here. So finally, can I consider that this is the x bar? Very easy. This minus this, this minus this, this minus this, this minus this. Total divided by 4. It is simple arithmetic mean. I can now here find a population, but let me not do it over here. Okay. So, or else, if you want to find P naught, Pn is equal to P naught plus Nx bar. What is P naught? This is P naught. This is the latest population that we have. 690,690,77421. The initial population plus N is how much? 2011, 2021, 2031. N is equal to 2, right? 2 decades. Therefore, it's equal to 2 into x bar is 113,19699. What answer you will get? It is P 2031. Okay. Actually, it is not given over here. So let me find it out. 6902 into 113,19699 plus 690,77421. So you will get a population as 9 crore 17 lakhs 16,081. This is the final answer. Okay, this is the population in 2031 for a controlled town or a city. Is it okay? Fine. Give it for some time. I think it's not very difficult. You can pause the video now. Let me continue with the remaining formula again. Okay. So if you want to go for now, the next part is the arithmetic mean is over. Next part is geometric mean. Okay. Now over here, what you have to see is from here to here, this population is increased. Okay. This population increase is how much percentage from 1971? As simple as that, the rate of the population growth, that is, this is going to be R. Okay, this is going to be, I'll tell you again here, you have to write the same line. This will be, say, B minus A. This is the increase in population, R of A into 100. Okay, so this will be 231, 79701, 231, 79701, that is 231, 79701 divided by 237. 237 98624 divided by 237 98624. This is 97.39. 97.39. Okay, percentage. So similarly for this one, it is 78,08,112 is increased from this population. So 469,78325 is equal to 7808,112 divided by 7808,112 divided by 469,78325. Is it correct? I'm getting only 16%. The growth of the population is only 16.62%. See, the problem with this type of numerical is, since this is one way, whatever I'm typing in, there is no one to, check my errors. During the class itself, a student say, "Sir, this is not 16.2, this is say 1.66 maybe, someone may be changing." So this error may crack inside, but you have to cross check over there, okay? So for example, let me see the question, 2379864, 2379864, and 23179,701. What I'm getting is the population increase is very high, 2 lakhs, 4 lakhs. It may be correct, it may be correct. Fine. So 23179,701 divided by 237,98624. 97% is correct. 7808,112. So is correct. 78,000 out of 46978. 46978. 325. Okay, anyway, and for this one, this part, it is going to be 86 lakhs 81,386 divided by 547 547 86437. This is 86,81386 divided by 547,86437. This is around 15.84, 15.84 percentage. And for last one is 5609598 divided by 63467, 63467, 823 into 100% is equal to 5609598 divided by 634,678. It's 8.83, 8.83 percentage. Okay. Now you please see over here. This is R1. This one is R2, red. This is R3. This is R4. Okay. Then what is R? R is equal to R1 into R2 into R3 into R4 to the power 1 by 4. Or you can say this is R1 Rn to the power 1 by n. Okay? So this is 97.39 into 16.62 into 15.84 into 8.83 whole to the power 1 by 4. Okay, 97.39 into 16.62 into 15.84 into 8.83 to the power 1 by 4. 21.81. Therefore, R is equal to 21.81. Okay. So when we take the average, actually in average, we take this plus this plus this plus this divided by 4. In terms of rate, it is R1, R2, R3, R4 whole root over the power 1 by n. Okay. So I'm getting around 21.81. Let me check again. 97.39 into 16.62 into 15.84 into 8.83 is equal to the power 0.25. 1 by 4 is 0.25, right? 21.81, correct. This value is correct. Okay? Please see this. Please see this. This is how I estimated the R. Where are my. Okay. So this is how I estimated R value. Okay? Now, let me use different colors. Now, P 2031 is equal to P naught plus, sorry, P naught 1 plus R by 100 to the power n is equal to how much? What is P? P is 690,77421 into 1 plus 21.81 divided by 100 to the power. What is n? N is 2 because 2000, this is therefore n is equal to 2, right? So this is the initial population into 1 plus R by 100 to the power 2. Okay. 21.81 plus 1 is equal to square root into 690,690,77421. Then this is 10 to 494,840. This is the final population that will be projected for 2031 by arithmetic mean method. Okay. So in Everest mean method, the value may be something different. In geometric mean method, it will be different. And geometric mean method is for place where the town and the city is not able to control. It can go without any limit. The population grows without any unlimited. There is no control. Okay, fine. So very quickly, I finished two numericals. I gave you the introduction, I gave the population forecast in the arithmetic mean and the geometric mean. This is supposed to be everything in two classes. The reason is, one by one, I'll come and check the answer script of your notebooks of the students, whether it's correct or not, whether you are able to do it, and you have to do the calculator. I'm doing it by myself, right? So one class itself will be equivalent to almost 3 hours of class. But however, this is going to finish the syllabus very quick. The disadvantage is, since you are not doing along with me, you may not practice properly and you may miss the points even though I'm giving my best. Okay. So this is the arithmetic mean technique. So to make the things look very easy, let me circle it. Okay. Now let me come to the incremental increase method. Let me rub this part. But the advantage for me is I can rub it and I can use it again and again. But you can't rub your notebooks. Yes. Wet duster. This is dry duster. Okay. Now the third part is incremental increase, or we call it incremental increase or decrease also. Okay. See over here, you see the things properly. In this part, the main important is the third column. This column is okay. Now, from here to here, the second part. Now I'll put it as 1, 2, 3, 4. Now this is going to be 1 and 2. That is, here I'm going to put 2 minus 1. After this is increased, amongst the increased value, again, how much it is increased or decreased? Okay, so this is 2 minus 1. That is 2 minus 1 is going to be increase in population let me see the calculator. 2, 3, 1. Correct. So 2 minus 1, since this is bigger, we are multiplying it. So 231, what we got is 153,71589, and this happens to be negative value. Okay, because this is higher. The increase in population, increase again in the first decade, is very high. However, it is decreased. So this minus this is becomes negative. Mind that. And in this part, you please write at the bottom again 8681386 minus 7808,112. This is 873274. This is positive. And for this part, so this one is smaller, so this is also be negative. That is 86,81,386 minus 56,09,598. 30,71,788. This is negative. And if you make these things combine, divide, and then you have to divide it by 3. Okay. So this is negative minus 153,71,589 plus 873,274. It is minus 175,70,103. Okay. Okay. Now I told you y bar. Y bar is equal to this minus 175,70,103. How many values are here? Here you can see this is 1, this is 2, this is 3. So this is divided by 3. It's equal to minus into minus 5856. 5856701. This is the y bar value. And remember, my students, this may happens to be positive, this may happens to be positive. If all are positive also, you have to sum it up and divide it by the 3 values. Okay. If it is negative, negative, positive, positive. The means is that some may be negative increment, some may be positive increment. The average of the 3 observation, this is the average y bar. Okay. Now in incremental increase method, what you say is P 2031 is equal to P naught plus nx. This is the arithmetic mean part plus n into n plus 1 divided by 2 into y bar. Correct? So this population already we had. I lost it. See, this is a problem. I lost it. So I cannot open my notebook. Even I cannot ask you. So population is 690,77421 plus n is 3, n is 2, x bar is 113,19699. Okay, this is the arithmetic mean plus, please have a look. This 6909 is this 2011 P naught, n into x bar is this 113,19699 plus, okay, plus n into n is 2, 2 plus 1 is 3 divided by 2 into y bar is minus 5856701. Okay, into 3 is total minus plus 690,77421. 5 lakhs plus 2 into 113,19699. Bracket close is equal to This is coming as, where should I write? 7 lakhs, sorry, 7 crore 41 lakhs 46,716. So by incremental increase method, I got this value. This is P 2031. So I have solved 3 equations. Am I correct? Let me remind again. To solve this problem, first we have to find an increase method. The increase and increase method, then you have to find it out. The formula is 2 minus 1, and this 3 sum may be positive or negative, divided by the 3, and you will get a y bar. And the formula is, this is the formula. So P naught plus n into x bar plus n into n plus 1 by 2 into y bar, you get this population. Okay, so by using 3 techniques, I have solved the population forecast, arithmetic, geometric, and incremental increase method. Fine. Now, in this video itself, let me cross check the video is still going on. Fine. In this video itself, let me cover some theoretical part also. You please pause the video and have a look in case if you want to continue it. Let me rub it off. Okay. And this incremental increase method is used for the place where the population growth is very, very progressive in controlled fashion. Okay, use the word progressive. Okay. Now there are some other techniques which we used. That is not numerical, but let me continue. The fourth one is arithmetic, 2 is geometric, 3 is incremental increase or incremental decrease. The fourth is, I'll say, it is comparative. This is theoretical, just you have to know the concept. Comparative. Okay. See, what happened is, this is in years, or you say in decades. This is the population. Okay. Now, you have, say, for example, 2071, sorry, 1971, IT1, 1991, 2001, 2011, say for example. So you have the values something like this. Okay, and you draw the line. This will not be asked in my exams, but what I try to mean is, engineering itself, it's very important to know, and sometimes in the 2 marks, since I've drawn the figure, it'll be very difficult to you to forget. The 3 numerical problems, one is comparative method, so you won't forget. Okay, comparative. Okay, now from here on, what will happen is, you will try to compare 3 different towns. This is town A, this is town B, this is town C, and this may be town D. You will observe that what is the nature of the place. These are different place, different towns. and cities. So what you do is here, compare your compare the other city, other place with your town and extend the line. Choose. If yours is very controlled, B is controlled. Say this may be arithmetic mean, this may be geometric mean, this is some very, very progressive. So which one is the best? You choose and you extend it on a theoretical. Okay? Is that clear? This is the existing for 2031. Compare with what type of, say for example, if we say the Iraq. So, or you say like, you know that this place you are going to develop a new industry. The population growth is very slow. But this place, like what you call it in Surat, new industry comes up for Tata, right? So you see that in Gurgaon, initially Gurgaon was completely barren land, but once the IT sector comes, how the population blooms. So similarly, your place is going to be an industrial place is going to bloom in the next 20 years. So even though the population rate is not very fast, from this nature you have to select which one you have to go for, and then you extend the line. Okay, this is one technique. Clear? So this is very simple, just a theoretical part. I'll put my LC over here. It's very and another technique is graphical projection or extension. Now what you have to do is here, this is the existing years. This is the population. These are your graphs. Okay, simple, simple. You're drawing here, simply you extend the line. So if you want to know for population of n in this place, this is the answer. Only one point is if the given population data is very long. Long say for example, say 1901 to 2011 it's given. Can you draw the graph? It may be difficult, right? Or it may not be in decades, it may be in years. So if the graph is very long, so what happens is your x-axis is very long. To shorten it, use semi-log graph. Bus. If you take the log of all its values, it will become very small, right? Only there is a difference, nothing else. This you have done in your particle size distribution in soil mechanics also. If the gap between first and last is very huge, you can shorten it by using the graph, taking logarithms, right? So this is one graphical projection extension. 5 techniques I've given you. 2 are completely theoretical. The last one is important in theoretical point of view. Now I'm explaining again the last one, and then with the close of population forecast. Okay. Where is my dust again? Okay, the last part is called number 6, logistic S curve. Okay, now you see over here why we call it logistic S curve. Here we are not trying to project any fresh population, or we are not trying to forecast the population. We simply present the present population, and we've seen that the graph is something like this. Okay, the graph is neither straight, neither is declining, neither it is horizontal. It's a little bit in this S curve. We observe that the previous curve is like this. This is called S curve. Okay, this is called S curve. Now, what it means is here we are trying to cut into 3 parts. This is A, number 1. This is B, number 2, and this is C, number 3. Okay, so here the rate of the change of population is directly proportional to P naught. That means here, if the population is 100, the rate of the population may be X. If the population is 1,000, population will be 10 times of X. That means the rate of the change in the population it also is proportional to the initial population. Example: if you have a pair of peasants, it will have 4 peasants, then 8 peasants, 16. At the beginning, if you have 20 peasants, then it will be pair 20 pairs means 20 into 2 40. Immediately it will be 40. Then it will be 80. So the initial concentration or initial population rate is very, very important. Okay. Now here in B part, the rate of the change of population is almost constant. Here it is almost constant. Okay. You got it. So this is constant. We're not saying anything. We're just trying to, post-mortem the graph. Okay. And here, this part what we said is the rate of change of population is directly proportional to PS minus P naught. A new terminology has come that is called PS. Okay. So what is this PS all about? We're going to check it. Okay. This PS is nothing. This PS is called saturated population. Here the concept is very interesting. What it says is that a place or a town, wherever, it cannot have unlimited number of population. Definitely it is going to have a saturated value. For a particular locality, for a particular community, for a particular district, the population will be once it will become saturated. Means, say for example, in your community, if the population is becoming increased, your uncle and auntie, they feel crowded, they shifted to other locations. They buy new land, they shifted. So something like a saturated population concept comes. So that saturation population comes. Okay. In this type of case, how we have to forecast the population? Here, the formula is very, very empirical and very tough. So I'm not remembering myself. I'll just write the formula. In case if you want, you can find the numericals. I'll give you the assignment. But if you have to give 2 marks or 3 marks, explain about the logistic S curve, you have to write only this part. Okay. Now, for formula point of view, let me give you. Okay. So what it says is, even I couldn't remember the exact formula. Now what it says is, if you want to find a population forecast, so P is equal to PS divided by 1 plus m natural log of inverse n into t. Look here. This is the p you want to find after n decades. You can say pn. This is the n decades or number of years maybe. If it's not decades, it can be number of years. This is t, that is number of years. Okay. Now, what is m? You may ask me, what is m? I'll give you one by one. What is m? PS is saturated population. And how can you find saturated population? PS. In this place, you have four unknowns value. P saturated, M value, N value, and T value. Okay. Clear? T is the number of years or days. So what is M, what is N, what is PS? In order to minimize the formula, we'll back this way. So PS is 2 P0, P1, P2 minus P1 square, P0 plus P2. Okay. Divided by P0, P2 minus P1 square. This is PS. Okay. What about N? N is equal to 2.3 divided by T1. This is log of base 10 divided by P0 into PS minus P1, bracket close, P1 into PS minus P0. This is very, very complex formula, even I don't by heart. And what is M? M is equal to PS minus P0 divided by P0. Okay, you please see again. If you want to find a population in 2031, how you have to find? The formula is PS, saturated population, divided by 1 plus M into natural log inverse of NT. So you have to find what is PS. So PS is twice P0, P1, P2 minus P1 square, P0 plus P2 by P0, P2 minus P1 square. And you know that P0, P1, P2 are all population. I'll tell you what is this P0. What is M? M is saturated population minus P0 divided by P0. N is 2.3 by T1. T1 also I'll explain. Log of P0 into PS minus P1 by P1 into PS minus P0. Okay. Now the question left is, what is P0? What is P0? What is P1? What is P2? And what is T1? Right. So here what happened is, when they give the population, say for example 1981, 1991, 2001. Okay, or I will say, or you can say 2011. So this you can consider as P0, this is P1, and this is P2. Oh my goodness, coming down. Okay, that's all. Fine. So from any three observation, you can make it P0, P1, P2, and T can be the gap year or decade difference. And then if you know these three values, you can find PS minus P0 by P0. PS you can find by using this formula. So firstly, the first point you have to find out, you have to find a PS1 PS. After knowing PS, you have to find M. Then you have the PS value, you can find N also. M and N you find it out, then this is the last step. Okay, so this one till now what I've seen is in any of the engineering service, they haven't asked question. This formula itself, it's not very easy for me to remember all the time. I mount it up whenever the time comes, but this way you can do it. Okay, but the logistic curve concept you have to be very clear all about, because by using this theory we also explain the saturation point of the population or a particular locality. Okay, now some other numericals are there which was asked 2 years before in engineering surveys regarding population forecast. It is not a direct question that this value data are given, you have to estimate the population by this technique. No, it is not that. It's a little bit twisted. So that I'll solve in the next class, or rather I'll discuss in your Google Meet. Okay. So with this, I'd like to thank my class over here.